afternoon again. My name is Rodolfo Eric Angat, your teacher in Earth and Environmental Science. Today we'll be learning about the Pacific Ring of Fire. So what is the Pacific Ring of Fire? This map here shows us not only the continents, not only the oceans, but it also shows us the occurrence of earthquakes. This place here that has a lot of red dots, this is what we call the Pacific Ring of Fire. So this is the Pacific Ocean, this is the Pacific Ocean. So these two are connected just like here. So Earth is almost like a sphere. So this whole thing is the Pacific Ocean. So in the map it was just cut. But surrounding the Pacific Ocean, these are all areas where plate boundaries are very active. So let's learn more about those boundaries. We have question number 1 for our assessment probe. Why do the oceanic plates subduct or sink under the continental plate? So we have the continental plate here, we have the oceanic plate here. The oceanic plate is made up mostly of basalt rocks. And because of that, it is a lot denser. While the continental crust or the continental plate is mostly made up of granite rocks. And because of that, it is less dense. The convergence of the two plates form what we call a convergent boundary. And in that area, the oceanic plate subducts into the mantle, melts, and the melted rocks rises onto the continent, onto the continental plate, and form continental volcanic arc. The rest of the rocks that turn to magma, they go and fill up the mid-ocean ridge in the Atlantic Ocean. So this process here is a destructive process because it melts or it recycles the old rocks. And that magma is converted into new rocks in the mid-ocean ridge in the Atlantic. So I hope with that explanation, you now know the answer to this question. Let's go to the next slide. So this is the next question that you need to answer with regards to our assessment probe. So, what is your answer? Okay, so for the first one, the oceanic plate is denser, that is why it sinks. And for the second one, the answer is letter C, because of the subduction of the denser oceanic plate. So the oceanic plate is denser, that is why it's the one that subducts. Now, our essential question for today is, what are the... Oh God, I had to say that again. Our essential question for today is, where are most of the volcanoes found? I hope you already know the answer. If not, we'll continue discussing this. Okay. So this is the map of the world again, and it is broken into several tectonic plates. So these tectonic plates have plate boundaries. So these are the plate boundaries. See these lines, the jagged lines, the broken lines, those are the plate boundaries. And we have a lot of plate boundaries. So let's begin with the first plate boundary. The plate boundary that's common in the Atlantic Ocean is a divergent boundary that is responsible for sea floor spreading. And this is where new rocks are constantly created. Here, we have the convergent boundary where there's a lot of volcanoes. Here in California, we have the transform or strike slip fault, which makes up most of the San Andreas Fault. Then we have another convergent there, You have another convergent there. Now, this convergent here is between two oceanic plates, okay, forming the Aleutian Trends. Now, this one here shows us the many earthquakes that happen in the Pacific Ring of Fire. 90% of earthquakes happen in the Pacific Ring of Fire. The Ring of Fire is also the home to 75% of the world's volcanoes. Do you know the answer to the question, why are there so many volcanoes in the Pacific Ring of Fire? I hope you will. We'll be discussing. So, this one is the western side of the United States. The eastern part of California is moving downward, while the western part of California, this part here, is moving upward. And this is an example of a transform boundary, specifically a strike-slip fault. Now, the upper part, close to Canada, or Canada already, we have the convergent boundary, subduction, and volcanoes formed here. That's your first clue. Why are there so many volcanoes around the Pacific Ocean? Now, in this one, we have a plate boundary. Guess what kind of plate boundary is this one? So this one is a continental crust. This one is a oceanic crust. The continental and the oceanic crust are going towards each other. Thus, since they're going towards each other, this boundary here is called a convergent boundary. And you will notice that this part here is so deep. In a convergent boundary between a continental and oceanic crust, a trench is formed. Trenches are the deepest parts of our planet. They are the deepest places. Most of these trenches have not been explored yet because going down to those trenches is not easy because of the immense pressure of the ocean. So as you go deeper into the ocean, the higher is the pressure, and only limited number of submarines can withstand that kind of pressure. So this is a trench here, and a trench is formed again when a continental crust collides or converges with an oceanic crust. Now, what happens to the oceanic crust is that it subducts or sinks because it's denser, and when it subducts, the oceanic crust melts and becomes magma. This magma becomes less dense and rises to form the volcano on the surface of the continental crust. That is why these volcanoes here are called continental volcanic arc, because they form on the surface of continental crust. So, this area here is called the Benioff zone. This Benioff zone is the one that I discussed before. The oceanic crust, the continental crust, they lack, they get stuck, and the pressure builds up, and when the rocks cannot withstand it, they break. That area where the pressure builds up is called the Benioff zone, and this is the location of most earthquakes. So this is the focus of the earthquake that results mostly to the tsunami that kills a lot of people. Okay? So shallow focus earthquake happens on the Benioff zones. Let's continue. Again, those X marks there are the places where shallow focus earthquake at the Benioff zones happen. Now, there's this famous volcano in Italy. It's called Mount Vesuvius, and it erupted And when it erupted in the summer of AD 79, it killed a lot of people. Contrary for what we know, lava is not the most fearsome effect of a volcanic eruption. Of course, this is up for debate. Most believe that the most fearsome effect of volcanic eruption is the pyroclastic material. It can be a pyroclastic flow, pyroclastic cloud, but it's the pyroclastic material. And I believe so because this pyroclastic material have turned the people in Pompeii like this. These are casts of their bodies. They have been burned and preserved alive. And I say preserved, that doesn't mean they are still there. These are all ashes, but formed in their shape. And this is what pyroclastic materials do the human body. Now, volcanic eruption can result to earthquakes and pyroclastic clouds, lava, and lahar. So, what are this? This is lahar right here. And this is a landslide. Both of them are governed by, or they are due mainly to gravity. But the difference between the two is that lahar is from the result of volcanic eruption, while this is mostly land and rocks moving due to gravity. But of course, just like what I said, both of them are in motion because of gravity, but this one is mainly, the materials that makes up the lahar is mainly due to volcanic eruption. What makes lahar so deadly is that when it is dry, it is very hard. So, it gives the feeling of being safe because it's so hard, so, and it won't move. But the thing is, when it gets wet, it becomes so fluid. It flows rapidly and it roars down the slope, burying everything on its path. And this is how it works, the lahar. And a lot of people have died because of the lahar because they do not expect that very hard sediment to just flow down so fast when it rains. So landslide is due to gravity, lahar is also due to gravity, but take note, this is not just regular soil and rocks, it is material made, or it is material that comes from volcanic eruption. How about the Hawaiian Islands right here? Is there a plate boundary there? The answer is no. The Hawaiian Islands are formed not because of plate boundaries, but because of hotspots. See the plate moving to the left and the magma rising towards the crust or towards the plate. As the plate moves, the magma rises, the magma fills up the plate and forms new islands, just like the islands that we now have in the Hawaiian Islands, and these islands are becoming longer and longer because of the hotspot. So we call that the hotspot. It's not a plate boundary. It's just a weak place on the Earth's crust where magma oozes out and form new islands and volcanoes, of course. Let's continue. Now, the biggest earthquake ever recorded was a magnitude 9.5, and it happened in 1960 in Chile. Chile, remember, is in the Pacific Ring of Fire, and this very strong earthquake has devastated the people there so much. It is believed that magnitude 11 earthquake would split Earth into two. Hopefully we don't experience that. Again, the Pacific Ring of Fire is where most earthquakes happen, where most volcanoes are found, and it is a dangerous place when it comes to geohazards. And again, this is the Pacific Ring of Fire right here, and this is where most earthquakes happen. And right here we have the Hawaiian Hotspot. The Hawaiian Hotspot, remember, that hotspot doesn't move, it's Earth's crust that moves, that eventually scatters the islands and they form them. Thank you so much.